Okay, great. Hi everyone, nice to meet you. And firstly, thank you for organizing this great competition, and I really appreciate it. So I will start my presentation now. And I'm in the second place. You can find my solutions on the Kaggle forum in the discussion section. And to begin with, a little bit about my background. I'm currently a PhD
We can
candidate.
only see the first screen. It's not in presentation mode. So if you want to toggle on the left-hand side on the different slides, great. Perfect.
Okay, but this is not the presentation mode, right?
Right.
Okay.
It's fine.
Yeah, okay, sure. I'm currently a third-year PhD student at Boston University, and my research interests focus on multimodal machine learning, including computer vision, natural language processing, and data mining. I'm also doing the AI for education stuffs, focus on the enhanced core reading instruction, which aim to help young students to develop their literacy skills. And I also work on some assistive technologies. For example, I developed a system to guide the people with visual impairments to navigate them to help them navigate to their destination. My previous experiences that helped me to succeed in this competition. I think the most important one is that I have more than 5 years Kaggle experience in various types of competitions. So I have experienced a lot of shake up and shake down. So that's how I trust my CV score, and finally I have a huge shake up to the second place. And my training method is pretty straightforward. The common tree-based models, including that GBM, XGBoost, and CatBoost, and also the NN-based models, the MLP, AutoInt, and DenseLight. I think the key part of my solution is that I also use the Jupyter model with the I attach the three NN layers at the bottom of the Jupyter as a feature, as a regressor. But I didn't use the Jupyter to do the regression. Instead, I use the second to the last layer features, which is a 512 vector. And I concatenate that vector to my other features and then train these tree-based models and NN-based models. And that helped me, these features help me boost my CV scores, but not the public LB. Instead, the private LB works pretty well with these features. For other features, the handcraft features, the most important ones I have shown here. It is worth noting that the length features, no matter the word length, word count, or sentence length, paragraph length, punctuation length, these length features are very important. So these features are the top 10 features from these three different models. If we take their union, that will be 16 total. So 10 from that GVM, 10 from XGBoost, and 10 from CatBoost. The tools I use, including the common GVM, XGBoost, CatBoost tools, and also that AutoML, which I use to train these NN models. and the training is pretty quick, about 15 minutes for 5 foot, for all these models, for all these tree-based models and based models. Okay. So the feature selection and feature engineering part, I mostly follow the public notebooks. So I really appreciate this is the strength of the community, the Kaggle community. We have a lot of open source very great notebooks that help me to develop my own method. And I can share the code here. Can you see it? No, okay.
No. But it's okay. You don't need to share the code.
Oh, okay. Maybe later. Yeah. So just those common features. And what I added is the punctuation length and paragraph length and those word count greater than 20 or greater than 10, some things like that.
Is that
so,
just real quick? Sorry to interrupt. When it says word count change 10, what does change 10 mean?
Word count change 10.
Yeah, you have like change 20, change 200, change 10, change 4, change 1.
Give me a second. Word count. Oh, this is the number of characters that changed greater than 10.
When you say change, it means somebody has gone back and removed the characters.
Yes. Oh,
Okay.
there's a because it's a sequence data. So we use some shift, and this shift is 10, 20, 50 to until 200, and I use this shift as a feature as well.
Okay.
It's the same to the public notebooks. Okay. And yeah, the training method. For these tree-based models, I use optional, which is the auto parameter tuning library to tune those parameters. And for the debutter, I added 3 layers at bottom. And the feature selection part, I just use the feature importance from these 3 models, and also added the debutter regressor features. Then finally, I retrain these tree-based models. So with the same parameters. And also I train these models with the Let Auto ML. And do we ensemble? Yeah, I ensemble a lot of models because before the competition ends, I think there must be a huge shakeup or shakedown. So I tried my best to train as models as I can, and with different states, with different splits. And if I remember correctly, my final model, my final ensemble includes like 10 to 15 different splits, and for each model. So that means 10 that GBM, 10 XGBoost, 10 CatBoost models, and for these N-based models, each about 10 models as well. That will be 60 times 5 in total because I also split it into foods. So I think that's one reason why I have a huge shakeup, because that makes my results more stable. And I think that's pretty much what I did, and I also have the all code shared on the shared publicly. So any questions?